Today I will talk about the photochemistry of carbonyl compounds. These are very important topic as the N to pi star transition or the excited states of carbonyl compounds display a rich chemistry in their own right. And since the oxygen atom in the of the carbonyl group has an unpaired electron, it behaves in much the same way as an alkoxy radical. Okay, so these are very important in terms of their reactions that may involve the hydrogen abstraction, addition to double bonds, as these are the typical reactions in such cases. In addition, the cleavage of neighboring carbon-carbon bonds may also occur. And the two most common of these kind of reactions are being designated as Norrish type reactions, Norrish type 1 and Norrish type 2. So today I will talk about this Norrish type 1 and Norrish type 2 reaction. Okay. So coming to the Norrish type 1 reaction, a Norrish reaction in organic chemistry is a photochemical reaction that takes place with ketones and aldehyde, of course, for the carbonyl compounds. And such reactions are subdivided into two types, type 1 and type 2. The Norrish type 1 specifically is the photochemical cleavage or homolysis of the aldehydes or ketones into two free radical intermediates, and this is more favorably known as the alpha cleavage of the carbonyl compound or alpha scission. Here the carbonyl compound or the carbonyl group accepts a photon and is excited to a photochemical singlet state, right? Through the intersystem crossing, the triplet state can be obtained from the singlet state. So if the transition from the singlet to the triplet happens, so we know that this is known as the intersystem crossing. So this can the triplet state can be obtained in that way. On the cleavage of the alpha carbon, the alpha carbon bond from either side will lead to two radical fragments, and the size and the nature of the fragments depends upon the stability of the generated radicals. So here in Norrish type 1 reaction, one thing is very important to understand, that this reaction is favorable in vapor phase, and in vapor phase this reaction will proceed via alpha scission and will lead to decarbonylation. So this is a significant or characteristic part for Norrish type 1 reaction, that it proceeds with decarbonylation process. And here we need to check the radical stability, which will be the pair of radicals that can be generated by means of alpha scission. Their stability need to be checked. Now the several secondary reaction modes are open with the radicals, with the fragments, depending on the exact molecular structure, and they will lead eventually to different products, like we can have the aldehyde, ketone, cyclobutanol, alkene, ketene, depending on the solvents and the nature of the substrate. Okay, and the excitation occurs through a triplet state, which eventually affects the lifetime of the transition complex, and therefore the reaction are quite fast and often proceed with quite a high quantum yield. Okay, so this is the basic of Norrish type 1 reaction. I will talk about Norrish type 2 when I will discuss the examples. So now here we will learn some examples of Norrish reaction of type 1. To start with the first example, where we can have a cyclohexanone compound whose alpha position have two methyl substitutions. Okay, so upon photoirradiation, the direct photoirradiation, we can have the two stable radicals if the alpha scission proceed on that side where the two methyl groups are substituted. So as these radicals which will be generated will be more stable, so eventually that will dominate in the product formation. And this biradical can have different fates, as you can see. If it can form, if it abstracts a proton from the other side where the alpha scission didn't proceed or facilitated, so that can lead to the formation of the ketene, and generally polar solvents helps them or facilitate this kind of formation. The other two products are generated or are resulted by means of abstraction of hydrogen atoms from the methyl groups, or adjacent carbon atoms. So the olefin and the carbonyl compound is the product where the terminal aldehyde group is found in the product structure. So this is a common set of reaction for Norrish type 1 reaction. We can have other examples where decarbonylation process dominates. For example, here you see three examples are here. If you can look over here, the first one, if I may highlight here, for this compound, this cyclopentanone compound, upon direct photoirradiation, you see the decarbonylation process takes place and yields a butadiene system. Okay. In another one, when the five-membered the ketone is cyclic ketone is fused with a cyclopropane ring, that upon direct photoirradiation eventually can lead to dipi methane system, and again the decarbonylation process is occurring here. So this is a common phenomena for Norrish type 1 reaction, that the decarbonylation takes place. Another example here, if you can see here, that the cycloheptenyl dienone system, and this can have two different fates depending on direct photoirradiation or photoirradiation in presence of sensitizer. We have learned the sensitizer, how it facilitates the photo irradiation or photoradical reaction. So we know about that. I'm not going into detail for that. But when the direct photoirradiation occur for this dienone system, cyclic dienone system, so then the transition or the excitation of the molecule from the ground state to the singlet state by the N to pi star transition, and eventually by means of decarbonylation process, acyclic triene system can be obtained. Okay, so this is one fate of the direct photoirradiation on the dienone system, cycloheptenyl dienone system. However, in presence of the sensitizer, upon photoirradiation, the singlet to triplet transition can proceed via the intersystem crossing, and which upon electrocyclic ring closure will form the four-membered fused cyclopentanone ring structure. So bicyclic ring system can be obtained. Here decarbonylation does not take place. Okay, so these are examples, the initial ones. I will talk about some more examples here. So if the compound or the substrate is cyclohexanone with only one methyl substitution at the alpha position, upon direct photoirradiation, these are the way or the path of forming different products. If you can see that the alpha scission can proceed into either direction. If it proceed at the part where the methyl group or in which carbon methyl group was attached, so that will eventually lead to more stable radical system, and this radical system can yield the more substituted double bond. Here you can see the thermodynamically stable trans double bond as the major product and the cis olefin as the minor product, whereas the less stable diradical system can lead to the formation of olefin compound in trace amount. So from here we can conclude that the radical stabilization after alpha scission in Norrish type 1 reaction is quite important when determining the majority of the product. Here is another example when cyclohexanone ring is substituted at the alpha position with two cyclopropane ring joined with each other, and upon photoirradiation or direct light on the compound, the alpha cleavage will take place and the more stable cyclopropanyl radical will form. Okay, so this upon ring opening and one cyclopropane ring adjacent to the biradical which is formed by initial alpha cleavage will the cyclopropane ring will open and will form an olefin and again create the biradical system. Then the cyclization takes place, which eventually form the cyclononyl system having an olefinic double bond and carbonyl compound, in which the cyclopropane ring is flanked with the alpha position of the carbonyl compound, and then further the ring opening and cyclization will eventually lead to cyclododecyl dienone system. So this is another example of Norrish type of 1 reaction. Next, we will learn about the Norrish type 1 reaction in the synthesis of natural product. So here is another example of Norrish type 1 reaction where a cyclic or a bicyclic system, rather say bicyclic ketone, can upon photoirradiation with the wavelength of 254 nanometer and in acetonitrile solvent lead to a a product, and that product eventually upon the reaction conditions of oxidation by means of PCC and DCM followed by reduction by means of palladium on charcoal and hydrogen will form the natural product, the bosniolactone, as the final target product. So here we can see that this reaction will proceed via the Norrish type 1 cleavage and will be followed by the hydrogen atom transfer reaction for the synthesis of the bosniolactone product. And if we can fill up the middle position, that the structure of the compound which will be initially formed by the photoirradiation on the substrate bicyclic ketone, and you can see here with a pyran 2-ol system with fused cyclopentene system, and this will be the intermediate structure which eventually will lead to the bosniolactone natural product by means of 2 steps of oxidation followed by reduction. And the mechanism will proceed via the following way, where the alpha scission, eventually the common fate for Norrish type 1 reaction, will proceed first, and then the biradical that will be generated by alpha scission eventually form or abstract the hydrogen atoms and form the terminal aldehyde group containing compound. Okay, and this is basically the cyclopentene system where with substituted by means of the methyl groups, the alkyl substituted formyl group, and then this can undergo the cyclization process and form the pyran fused cyclopentene structure with hydroxide functional group as the at 2 position. And first the oxidation of the hydroxy compound to ketone, and then followed by the reduction of the olefin in the cyclopentene ring will lead the bosniolactone as the product. So this is an example or application of Norrish reaction type 1 in the synthesis of natural product or bioactive molecule. So now I will talk about the Norrish type 2 reaction, and this Norrish type 2 reaction is a photochemical intramolecular abstraction of a gamma hydrogen where a hydrogen atom is 3 carbon positions away from the carbonyl group, usually that is the gamma hydrogen, and by the excited carbonyl compound, and eventually it produces a 1,4 biradical as a primary photoproduct. Okay, now this type 2 reactions depends on the close approach of the carbonyl oxygen to a gamma hydrogen, and the conformational mobility in general permits this to occur within the lifetime of the excited triplet. So this is very important. Okay, so first we see with an example. Here we can see that the substrate is optically active ketone 5-methyl 2-heptanone, and you can see the gamma hydrogen, of course, I believe. So this is the gamma hydrogen you can see over here. Now on photoirradiation, the N2 star transition in the carbonyl group will proceed and form a 1,4 biradical by means of abstraction of gamma hydrogen, so in the singlet state. And this biradical 1,4 biradical can have several fates if it can go for the radical scission and the formation of olefin and ketone. This is one route. It can form the cyclobutanol system, so the recombination of the biradical eventually will lead to the cyclobutanol system. This is possible. Or if the Norrish type 2 reaction proceeds, then the singlet to triplet excited state transition will follow, and the same spin, the radicals will have in the same spin mode, and the product of racemic 5-methyl 2-heptanone will be the major one. Okay, and here also from the triplet state by rotation it can form the cyclobutanol as the major product as well. We will see another example here with a ketone where cyclopropane is flanked with the ketone cyclopropanyl carbonyl compound. Upon direct photoirradiation eventually will form the alpha beta unsaturated ketone compound as the major product, and this will follow the Norrish type 2 reaction. Here another example, if you can see the carbonyl compound on direct photochemical reaction will form the 1,4 biradical, which upon recombination can form the cyclobutanol as the product, or in other case the radical scission, the adjacent the sigma bond breakage. Here the sigma bond that will break is that one. So if this bond breaks, and eventually that will lead to the enol system and the olefin. Now the enol can tautomerize to the carbonyl compound or ketone depending on the nature of the R group. So we can see in Norrish type 2 reaction from the carbonyl compound having gamma hydrogen atom under photoirradiation can form different products. Here you can see the cyclobutanol, you can see the carbonyl compound or the ketone, you can see the enol system, or you can see the olefin. So this is the variety of products in Norrish type 2 reaction. Another example with that one where the carbonyl group is substituted with a tertiary butyl group, and here the radical stability is very important, and that's why the example has been chosen here. So from the singlet excited state after N2 pi star transition, from the singlet excited state, the 1,4 biradical can have two fates like the previous example, and the cyclobutanol can be the product, the ketone and an olefin. These are the common product from there. Now if this excited singlet state undergoes the intersystem crossing, move to the excited triplet state, and then a trimethyl carbon radical or tertiary butyl radical can be formed in addition to the carbonyl radical. Okay, so the alpha scission at the other side of the tertiary butyl group forming the more stable radical, eventually leading to the isobutane formation. So from this radical can form isobutane, and the carbonyl radical can abstract the gamma hydrogen, and it can form the carbonyl compound. Olefin can be the other one of the products, and there can be other fraction or fragments as the product in this photochemical reaction. Next we will see another example where this bicyclic system substituted with a ketone functionality which is attached with a phenyl group, of course, upon photoirradiation can lead eventually to the formation of cyclopentane ring and substituted by the alkyl substitution, which contains eventually the phenyl group and the carbonyl ketone group as the functional group. So these are example for the Norrish type 2 reaction where the gamma hydrogen abstraction takes place from the position. You can see where the pi bonds are shown over here. So the gamma hydrogens are abstracted from there. This is another important example of Norrish reaction type 2 where the phenyl 2-butenyl methane sulfonate is the substrate where the terminal methyl groups are there as well with this, and upon this Norrish type 2 reactions the gamma hydrogen abstraction from either this methyl group eventually lead to the alcohol and this 1,4 biradical, and the elimination of methane sulfonic acid will lead to the formation of the carbonyl or the keto group and the 1,3 biradical system. This 1,3 biradical system on recombination will produce the cyclopropane ring as the major product, which is substituted by PHCO and methyl, those two substitutions. So this is another example of Norrish reaction type 2 which is very important, and this is all about the Norrish type 1 and Norrish type 2 reaction. So thank you very much for watching TG Chemistry, and if you like the video, don't forget to subscribe my channel and to press the bell icon to get notification whenever I upload the new video. Thank you.